Hey there everyone. In this multi-part video series, we are going to build a serverless application using CDK, and we are going to build it on AWS. Now, when provisioning infrastructure on AWS and using IAC, you have multiple options. You can use Terraform, you can use CloudFormation, you can use SAM for serverless applications, which we are building in this case. And you can also use CDK, which is one of my personal favorites. And it's also a very good option if you are a developer or you come from a development background. You're going to love CDK. Also, if you find any of the information in this video useful or any of the other videos that I've posted so far on this channel, I would really appreciate if you would please subscribe to the channel. It's a new channel and each subscription is going to help a lot. So really appreciate that, and let's get started. So let's quickly go over some details of what we are trying to build here, and then we will just dive right into the CDK code and the application code. So first, the technology choices that we are making for our application. For IAC, as I mentioned, we're going to use CDK. For database, we are going to use DynamoDB, which is AWS managed NoSQL service. For compute, we are going to use Lamda, no surprises there. And for authorization, we are going to use Cognito user pools. Right now we are focused on the API. That's why I use the term authorization and not authentication, which is done by the front end application, which we are not doing as part of this video. Let's just outline our hypothetical business requirements here. So we want to implement REST API methods for a subset of the functions that are required for an online store. So we are just talking about these three, which is create order, being able to update existing orders, and just being able to query orders by date range for specific users. Based on the requirements that we just discussed, let's outline what our REST API would look like. For create orders, we are going to have a post method on orders resource. To update, we're going to have a put on orders, but we would be specifying the specific order ID. And then for get, for retrieving orders, we're going to have a get on orders, and we're going to pass a start and end date as query parameters. And the user ID would get picked up from the authorization header, because our authorization header is going to lead us to the user ID, and that's where we're going to pick it up from. Real quick, our database design would include just one table, which we're going to call orders table, and it's going to have these fields: the customer ID, order ID, customer ID, the order date, the order ID, and the order items, which would represent the specific items within an order. And here I'm not using any standard notation, but yeah, what this is depicting is there's a one-to-many relationship between an order and order items, which is very common if you have ever worked on an e-commerce application. Furthermore, let's quickly touch on our primary key as well as the one global secondary index that we are going to create on the table. So our primary key is going to be a composite key, which would be composed of the customer ID, which would serve as the partition key, and the order date as a sort key. This is primarily to support this access pattern that we initially defined as one of our requirements. Also, we are going to create a global secondary index on the order ID attribute, and this is just to support the update order operation as the put call that we identified earlier, because when we would be updating an order, we would receive the order ID, and we need to do an efficient lookup using the order ID, and for that we're going to have this global secondary index. Alright, this is all what I wanted to go over initially. just to provide some context of the hypothetical application that we would be building. And now let's just jump into the IAC code and the actual application implementation. We're going to start off by creating the directory that is going to host all of our source code for the CDK as well as for the application, the Lambda function implementations and all other code which would constitute our application. So let's first create the folder. We're going to call it CDK my shop, and we just cd into the directory, and now here we're going to initialize our CDK app. For that we need to run the CDK init command. We're going to use TypeScript as our language for within CDK. The app has been initialized. Now we're gonna open the directory for the app in our IDE and get to work. So I've opened the application folder in Visual Code, and here what you see right now is the boilerplate stuff which CDK init creates for us. I already have another video on CDK basics. So if you are lacking in any of the basic knowledge, which I'm going to skip in this video as far as CDK is concerned, you can go and check that video out and get some basic foundational knowledge about CDK. So first thing which we're going to focus on as far as our IAC is concerned, we are going to first create the persistence for our application. Our application obviously is based on DynamoDB. So right now we are going to write code to create the DynamoDB table, the index that is required for this application. So I'm going to add a private method just to keep the code well organized and neat. I'm going to create a private method which we're going to call in the constructor. I'm going to call it create persistence, and then add all my persistence related code in here. And obviously we're going to follow the same approach for the rest of the infrastructure as well. So before we create the table, just want to highlight the structure of the DynamoDB table. It is going to have a attribute called customer ID, and this would be our primary key. It is also going to have another attribute called order date. I'm gonna name it ISO, and this is going to be the sort key. Also, we are going to have another attribute called order ID, and this would be the primary key of the index that we are going to create, the global secondary index. And then in addition to that, we're just going to have another nested attribute which would be order items, and this is going to contain all the individual items that belong to the order. With that, let's go ahead and write the code that is going to create the DynamoDB table that our application needs. So I'm gonna need this table in subsequent code which would be in other methods. So that is why I'm going to store a reference to this table in a member variable. First, we would have to specify the partition key. And as you can see above, our partition key is going to be customer ID. Type is string. Next, we are also going to specify the sort key for this table. We can also use order date, but I think it makes more sense to explicitly state in the name that it's going to be a string in ISO format. Just to further clarify on that, it's going to be a date stored as a string in ISO format. Just wanted to be totally clear and correct there. We're calling this table orders. We're going to specify a read capacity as very low, and same for write capacity. Let me import the corresponding module for this class. That is why the autocomplete was not functioning. And we also should add a removal policy for this table. What I'm going to add right now is specifically for the purpose of this demo. This should not be used in production scenarios, because it's going to delete your table when the stack gets deleted. So not good for production scenarios. And this is capital P, it needs to be small. Let's remove these extra comments, and we need to declare this member variable. This is TypeScript. It's strongly typed. And last but not the least, we need to call this create persistence method that we just implemented. Let's go and deploy the stack and then see this DynamoDB table gets created. And deploy. Deployment completed. Let's go to the AWS console and see the resources that got created. Mainly it's DynamoDB table that would have gotten created and that we want to check out. So we'll go to the DynamoDB console, and from there we'll go to tables. And here is the table that we just created using CDK code. So one thing that's missing is index. We need to create one global secondary index, which we don't have on this table yet. And that is the next thing we're going to do in our CDK code. To create the global secondary index, there is a method defined in the table class, and it's called add global secondary index, and we're gonna call it and specify the attributes of our index. This is going to be the name of the index, and the partition key, as we discussed earlier, is going to be the order ID attribute. This global secondary index doesn't have a sort key, but if there is ever a requirement to define sort key, we have that option with the global secondary index as well. And just like the table itself, GSI has its own provision capacity. For now and for the purpose of this demo, We are just going to use very low values. That should be all that is required to define an index. Let's go back to our terminal and redeploy. Build to generate JavaScript from our TypeScript code, and then after that it's going to be deploy. Let's go back to our AWS console and see the index that we just created on the same DynamoDB table. So if we go to indexes, we should now see the index that we just created. I actually came here after a few minutes, so if you go to this tab right away, you might see the status for an index in creating status. Asynchronously creates the index on an existing table. So with this change deployed, we have actually created the DynamoDB table that we need for our application. And we are done with the persistence part of our infrastructure. And now we are going to focus on other parts of our infrastructure, which is going to be the compute, which are Lambda functions, the REST API, and the Cognito pool for authorization.